Scientific notation. One challenge that is faced by scientists multiple times is that the numbers that they're working with sometimes are either really large or they're really small. For example, the number that you see here, it's the distance from Earth to Sun. This is a really big number, whereas this number right here is a really small number. So these numbers are a little difficult to remember, a little difficult to express. So to make our life easier, scientists Before that, let's look and understand what is exponential notation. Exponential basically means anything raised to the power of a number. In this case, we are majorly focusing on 10. So 10 raised to power 0 is 1. Anything, let's say x raised to power of 0. Anything raised to the power of 0 is always 1, which means 10 raised to power 0 is equal to 1. If instead I do 10 raised to power plus 1 on the top here, anything raised to the power of 1 essentially means that same number. So 10 raised to power 1 means it is equal to 10. 10 raised to power 2 means I have 10 multiplied by 10 2 times, which basically will give you 100. So that's this. 10 raised to power 3 means it's 10 multiplied by itself 3 times, which is also equal to 1000. So if you can write the number 10 raised to power 3 or you can write the number as 1000, that essentially means it's the same thing. If I say 10 raised to power 5, that means I have 10 multiplied by 10 5 times, which is also 1, 2, 3, 4, 5. So either you write 10 raised to power 5 or you write this, it's basically the same thing. Only difference is here, this is the exponential notation and this is the standard notation. This is when the power is positive. If your power is negative, that essentially means you have that number, you have 1 over that number. If I have 10 raised to power negative 1, that means it's 1 over 10 one time, which would give you 1 over 10, which is 0.1. If it's 10 raised to power negative 2, that means I have 1 over 10 but 2 times. So that is 1 over 10 times 10, which is 0.01. Similarly, 10 raised to power negative 3 means I have 1 over 10 3 times, which will give you this number. One thing that you might have noticed here is anything raised to power something positive, if it's a positive exponent, for example in these 3 cases, that just means it's a large number, it's a big number. If your exponent is something negative, that means it's a small number. Like you can see here, as the exponent becomes negative, it becomes 0.1, 0.01, 0.001. So just remember this, positive exponent means large, negative exponent means a small number. Now let's see how you can write the number in scientific notation. It's very easy steps. The first step is locate the decimal point. For example, let's start with this number. I locate the decimal point is located right here. Now, in scientific notation, the decimal point is right after the first non-zero digit. So I need to move the decimal after the first non-zero digit. Okay, so I need my decimal right here. So now let's move it. 1, 2, 3, 4, 5, 6, 7. So I need to move my decimal by 7 place values, and then I would get my decimal at the right spot, which means my new notation becomes 1.42 because I moved the decimal here, multiplied by 10, and this was moved by 7 places, so 7 becomes my exponent. Let's confirm. 1, 2, 3, 4, 5, 6, 7. Correct. 7. Important thing here is you can see this number, beginning of this number, it's a very small number. It was 0.000, which means my exponent should be negative. So I would put a negative right here. This is called the standard notation, and this right here is the scientific notation. Okay, so multiply the new number by 10 raised to power n, and the n is the number of places you move the decimal point by. If you move the decimal point to the left, then n is positive. If you moved it to the right, n is negative. I do not like to remember left or right. An easy way is if the original number is 1 or larger, meaning it's a big number, your n is positive. Large number, it's a positive exponent. If your n is negative, that means it's a small number, meaning it is less than 1. That's it. Left and right, you don't have to memorize. Let's try this one. On top, for example, this, the first step is I need to locate my decimal. There's no decimal right here, which means this is my decimal. It's not given to me, so I'll put it at the very far end of the number. Where do I want it? I want it right after the first digit, non-zero. So I'll move it 1, 2, 3, 4, 5, 6 place values, which means my number is 2.5 times 10 raised to power 6. And because my original number was a very large number, that means my exponent is positive. If you don't see a sign, that means it's a positive number. So if it's just written as 2.5 times 10 raised to power 6, that's also okay. You don't need to put a plus sign. Let's try this. I'll put the decimal right here. I want it at this location, so I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means 1.37 times 10 raised to power positive 11, because it's a very large number to begin with. The last one, I want the decimal here, so I need to move it by how many places? 1, 2, 3, 4, which gives me 3.26 times 10 raised to power 4, but it's a negative 4 because my number is a small number to begin with. And that's it. This is your standard notation, and these are your scientific notation. Now let's see how you can go from scientific notation to standard notation. How can we do reverse? Let's try an example. This is the population right here, 301,786. Express this number in scientific notation. So no decimal, which means I'll put the decimal right here. And I want scientific, which means I want the decimal here. So I have to move it 1, 2, 3, 4, 5, 6, 7, 8 by 8 places. So my number is actually 3.01786 times 10 raised to power 8. And it's a positive number. Why? Because my number is large. The original number is large. So that's your answer.